Okay, so today I'm going to be discussing covalent bonding. Previously in the last lesson we looked at ionic bonding, which occurs between a metal and a non-metal, and we looked at how sodium transferred one of its electrons to chlorine. Okay, now it's very important to understand this concept. Now this is a bit of a challenge question. Hydrogen has one electron and the other hydrogen has one, and in the first shell can hold a maximum electrons of 2. How can they have a full outer shell? Pause the video and have a go. If you can answer it right, that's fantastic. So think about it, they've got one each, so what can they do? Of course, well done, they can share it. Brilliant answer. They can share the electrons, and now both hydrogens have a full outer shell. Now the atoms share electrons, so there is a strong force that joins the atoms together, making a full outer shell. This is called covalent bonding, which takes place in non-metals. So covalent bonding happens with non-metals, and it's all about sharing your electrons in order to have a full outer shell. That concept is extremely important. Now what about this? Oxygen has 6 electrons in its outer shell. Another oxygen has another 6 electrons in the outer shell. How can these share the electrons in order to have a full outer shell? Think about it. How much do they have to share each? Pause the video, have a go. Of course, well done, fantastic. They can both share 2, and then it will have a full outer shell. So I'll just click on the oxygen. Remember, this will be a double covalent bond, as each oxygen will be sharing 2. Now the ones that they're sharing are typically drawn in the center, as you can see on the overlap. It's extremely important that you understand that concept. But well done if you got that right. Now last but not least, have a go at this question. How do you think water is a compound? So we know it's H2O. We've got 2 hydrogens and 1 oxygen. How would you draw that? So oxygen has 6, so it requires 2. Hydrogen has 1 each, so think about it really. How would it look like? Exactly, well done, fantastic. The hydrogen will share 1 electron across, and so will the other hydrogen, and now H2O, the covalent compound, has a full outer shell. Well done. Now let's have a go at this question over here. Fluorine has an electron configuration of 2, 7. Fluorine gas exists as a diatomic molecule. That means just pairs up with 2 in each molecule of fluorine. The 2 fluorine atoms are joined by a covalent bond. Draw a dot cross diagram to show the electrons in a molecule of fluorine. So how would it look like? Okay, so think about it. Fluorine needs 1, right? And there's 2 fluorines. Think about how they would look in a covalent bond. How would 2 fluorines look like in a covalent bond? I'd love it if you could draw it. There's the answer, well done. 1 pair of 2 electrons are shared, so 1 pair of 2 electrons are shared between the 2 fluorine atoms. Rest of the structure drawn correct. Okay, so it's very important to remember it would be a single covalent bond, and it would be drawn, they will be sharing 1 each, okay, or a pair. Now here's some differences between covalent and ionic bonding, which is extremely important that you get your head around. Anyway, thank you very much for watching this video. Please like and subscribe, and peace out.